Hi guys, welcome back. This is Math 172, final exam review. We're working on a parametric application problem, which is about projectile motion. Usually, this is a favorite for physics teachers and math teachers because it's beautiful. There are lots of steps, but we're going to work through them one by one. All right, so I have a baseball player who's up on the pitcher's mound, and he's throwing a ball. And he's a baseball player because he's wearing a baseball hat. Okay, cool. So the ball has an initial height of 5.5 feet. And it travels 150 feet per second at an angle of 22 degrees with the horizontal. Then it goes up to a maximum height, then it falls down until it hits the ground here. All right, so this is the picture, this is the movie that you should be playing in your head. Now, the equations that govern this kind of motion are very well known. We know that x, the horizontal distance, x is equal to v naught, the original velocity, times the cosine of the angle, which is 22 degrees, times time. So if we want to go ahead and put in 150 times the cosine of 22 times time, this gives us an equation for x, which is 139t. So this is our equation for x for this problem. In the vertical, it's a little more complicated. Y equals negative 16t squared plus v naught sine theta t plus h naught, the original height. So plugging in what we know, this is negative 16t squared plus 150 sine 22t plus 5.5. So this simplifies to negative 16t squared plus 56.2t plus 5.5. So this is our y equation for this problem. Now we haven't, and so this is part A. Just determine what the equations are for this problem. Great. Question B asks, how long is the ball in the air? So from the beginning until the end, how long is it in the air? So what they're asking about is for the time it takes for the ball to hit the ground. So our x equation doesn't tell us anything about the height of the ball. All of that information is encoded in y. So when the ball hits the ground, y is 0. So what we're going to do to find the time it takes the ball to hit the ground, we set y equal to 0 and solve for t. So that tells us 0 equals negative 16t squared plus 56.2t plus 5.5. Now this is your opportunity to use the solver on your calculator or to use your old friend, the quadratic equation. So I'm going to use the quadratic equation. So t equals negative 56.2 plus or minus the square root of 56.2 squared, negative b plus or minus square root b squared, minus 4 times negative 16 times 5.5, all over 2 times negative 16. So when you work this out, you get negative 56.2 plus or minus 59.25 over negative 32. This gives us two roots. So we've got positive 3.05 over negative 32. We can't have negative time. No negative time. negative 115.45 over negative 32. So this gives us 3.61 seconds. So the ball is in the air for 3.61 seconds. So again, from the time it leaves the pitcher's hand, goes up, and then comes down. So this time is 3.61 seconds. Okay? That's useful. Because in the next part, they ask us, in that time, how far forward does it travel? So what is the horizontal displacement during that 3.61 seconds? So we're going to use our equation for x here. So in part C, they ask us, they ask, in 3.61 seconds, right, in the time that it takes to hit the ground, how far did the ball travel horizontally? So we're going to use this equation, right? X equals 139 times time. So we've got 139 times, while it was going up and coming down, it was also moving forward. The thing that ties the two dimensions together is time. So we're going to multiply by that 3.61 seconds. So time is from part B. And we get 501.8 feet forward. So that's the answer to part C. In part D, they ask, find the maximum height. Okay, so the maximum height occurs right here. And if you look carefully, you can see that this is the vertex of the y parabola. So this is your max height. And it occurs in y. So to find max height, maximum height so we're going to be using our y equation, negative 16t squared plus 56.2t plus 5.5. And we're looking for the vertex. Vertex is negative b over 2a. So this is negative 56.2 over negative 32. So this is 1.75 seconds. This is the time it takes, but they asked us for the height. So we have to take this time and substitute it back in to this equation. So we've got y equals negative 16 times 1.75 squared plus 56.2 times 1.75 plus 5.5. And that tells us that our maximum elevation is 104.35 feet. So this is our max height. Great. The last question is, where is the ball? He asks. Location, 1 second after launch. So looking back at our sketch, we know that the maximum height occurs at t equals 1.75 seconds. So we know that at 1 second it's going to be back here, right? So we're looking for the location, x and y, 1 second after it was thrown. So what we're going to do is just use both the x equation and the y equation and substitute in time equals 1. So we know x equals 139t, so that's 139 times 1. So it's 139 feet forward of the launch point, and y is negative 16t squared plus 56.2t plus 5.5. We sub in 1 second. We've got negative 16 times 1 squared plus 56.2 times 1 plus 5.5. And we get vertically the elevation as 45.7 feet above the ground. All right, so guys, this is the answer to part E. 1 second after it was launched, the ball is 139 feet forward of the launch point and 45.7 feet above the ground. I hope this has been helpful. Again, it all begins, ladies and gents, it all begins with a sketch. If this is driving you bonkers, please come into the ILC. We would love to help, and it's free. Please come see us. Okay, bye.